Hi guys, and welcome to your second installment in Chapter 6. Today we are going to look at Lewis dot structures. We're going to take those simple dot structures and we're going to start combining them and making molecules. So what is a Lewis dot structure? Well, Lewis dot structures combine electron dot notation of both of those elements. What we're going to do is look at the dots between elements as representing a covalent bond. A shared pair is going to be symbolized as a dash. So any electrons that we share, so those between the elements are going to be the ones that are shared, we're going to show them as a dash. And when we write the dash, we have to remember that that means 2 electrons, because we're going to get one from one element and one from the other. And we're going to put this together to build a structural formula. So it's going to show Lewis structures without any of the lone pairs. A lone pair would be electrons that aren't involved in bonding. So we alluded to different types of bonds. First type is a single bond. Remember, the characteristics of the bond were length and energy. So a single bond is going to have the longest bond length. So these elements are going to be the furthest apart from each other. And it's going to have low bond energy. So it's not going to take a lot to break this bond. The next type is a double bond. Double bond, of course, would be 2 shared pairs. And then we have a triple bond. Triple bond would be sharing 3 pairs. So this is going to be the shortest bond length, so the closest together we can get. And it's going to have the highest bond energy. Now you say, why can't we have a fourth? Why can't we have 4 bonds? Well, that's because if you think about the P block, you can have 3 empty spots, but if we're in the P block, then that means our S's are already filled. So we don't have room for 1 S and 1 in each of the P's. We would fill our S first. So there's no way we're going to have that quadruple bond, if you'd like. So how do we draw dot structures? Few easy steps. First thing we're going to do is look up the total number of electrons that each element would give us. Now, instead of assigning them to a particular element, we are going to take all of those and put them in a pot. Then we're going to take electrons out of the pot and connect each element with a dash. And remember, each dash equals 2 electrons. So that means every time we attach elements together with a dash, we must subtract 2 electrons from our pot. Then any electrons remaining in the pot are going to be placed around your outer elements to fill their octet. So it's got a lot of steps, but once we start using them, everything will make a little bit more sense. So let's practice doing some dot structures. So what we need to know is how many electrons are going to go in my pot. So let's put a pot over here. And we are going to put some electrons in this pot. So C, what we're going to do is we're going to look up the group number. And when we do that, C is in group 4. So it's going to put 4 electrons in the pot. H is going to put 1 electron in the pot. But since we have 2 of them, we're going to multiply that by 2, which gives us 2 electrons. So H is going to put 2 electrons in the pot. Then we have O. O is in group 16, so it's going to give us 6 electrons to add to the pot. So that means in my pot I have a total of 12 electrons to use. So now I'm going to start building my structure. The easiest way to do this is to look at your first element and put that in the center. So we're going to take C and we are going to put that in the center. Then we are going to take our other elements and put it around. So now I'm going to attach H and I'm going to attach H, and I'm going to attach O. Doesn't matter where I attach them, not really, as long as we think of that box again and we put one on each side. Now, we're going to have to think about how many electrons did we remove from this pot. Well, each dash is 2 electrons. So I have taken out 2, 4, 6 electrons. So already out of my box is 6. So I need to subtract 6, which is 2 for each dash. So how many are left in the pot? I only have 6 left in my pot. So I'm going to take those remaining electrons and put them around the outside. Now hydrogen, once it makes a bond, it's one of our exceptions, it doesn't want any more electrons. So I don't have to worry about this hydrogen, and I don't have to worry about this hydrogen. So what I'm going to do is put my remaining electrons around oxygen. So I'm going to, this time, kind of throw that Hund's rule idea aside, and I'm going to pair them up. 1, 2, 3, 4, 5, 6. So now I have used my 6 remaining electrons in my pot. The last thing I'm going to do is make sure everything has an octet. So H is an exception. It's good, and the other H is good. Oxygen, since it's sharing these electrons, has 2, 4, 6, 8 electrons. So oxygen is good. Carbon has these electrons. So it has 2, 4, 6 electrons. Well, that means carbon still does not have its 8 electrons. So what's carbon to do? Well, carbon's going to steal some more from oxygen. Hydrogens don't have any more electrons, so what it's going to do is it's going to basically remove 2 lone electrons and move them to a shared position. That doesn't change anything for oxygen, but now it allows carbon to have 8 electrons. So let's look at CO2. Again, I'm going to think about what needs to go inside my pot. So C is in group 4. So it again adds 4 electrons to my pot. O gives us 6, but this time I have 2 O's. So I'm going to multiply it by 2. So I get a total of 12 electrons that I am going to put in my pot for a total of 16 electrons. So now I'm going to again place C and O and O. Again, first element going in the center. Now, since I have 2 dashes, that means I am going to subtract 4. Again, 2 for each dash. So now I have a total of 12 electrons I'm going to put around. Again, starting on the outside and pair them up as we go. 2, 4, 6, 8, 10, 12. So I've used all 12 of my electrons. So now I'm going to check for octets. Oxygen, 2, 4, 6, 8. That's good. Oxygen, 2, 4, 6, 8. That's good. Carbon now only has 2, 4. So once again, carbon needs to steal and make some more bonds. So we're going to take 2 off of oxygen, and we are going to form a bond. Oxygen still has 8. Now carbon has 2 more. Now what we're going to see happen in this case is that it's going to steal from the other oxygen also. So instead of taking 2 more from the first oxygen and making a triple bond and a single bond, because they are both CO bonds, it's going to try to make them as equal as possible. So that's why I stole it from the other electron, or the other oxygen, and moved that. So now I have equal bonds between them. I both have 2. But again, now carbon has 2, 4, 6, 8. So everything is once again happy. One more for you? Okay, let's do it. Let's get our pot. And H delivers 1 into my pot. C delivers 4 into my pot. And N delivers 5. So that gives me 10 electrons in my pot. In this case, I can't put H as the central atom because H can only make 1 bond. So I have to move on to the next element. So once again, we find C in the center and then attach the H and the N to it. So how many electrons have I used? I've subtracted out 2, 4 for each of the electrons, so minus 4. So I am left with 6 electrons in my pot. I can't put anything around H, so I put it around N. 1, 2, 3, 4, 5, 6. I have used them all, so all 6 are gone. So now I check for octets. H is happy. Once it forms its bond, it's good. N is happy. It has 2, 4, 6, 8. And once again, we have poor lonely C that does not have a full octet. So it wants how many more electrons? Well, we have 2, 4. It needs 4 more electrons to get 8. Well, it has nothing to steal from H, so it's going to steal from N. So we've got 2 from N that are going to rotate down. Now we are at 2, 4, 6. And we have 2 more from N that we can steal. And now I have 2, 4, 6, 8. N still has 8 because it, remember, is in this circle. So we've got 2, 4, 6, and 8. So this has a single bond and a triple bond. And that's fine because those 2 bonds are going to be different. An HC and a CN bond are going to be different. Now, the tricky stuff. Sometimes when we're drawing these, we get what we call resonance. So one Lewis structure isn't going to correctly represent the bonds that we have there. So if we were looking at SO3, we do the Lewis structure and we get something that looks like this. So as you can see, we had to take and we had 2 electrons here. We would have stolen those to make another bond to S so that S had its full octet. Well, now all of these bonds are S and O bonds. So how do we know which one to steal from? Well, we don't. We can pick one. And because we can pick one, that's why one Lewis structure wouldn't correctly represent it. So we could have had the double bond at the top, or we could have had the double bond to the other side. So if we were to draw a Lewis structure for SO3, we would need to show that it has this resonance, and we would have to actually draw the 3 structures. Ionic bonding does not share electrons. So we've got a complete transfer of electrons. That doesn't mean that they don't bond. They have that positive and negative from the cation and the anion. So the positive is going to be attracted to the negative, and we still get an electrically neutral element. And when they come together, instead of forming a molecule, they get this crystal lattice. So it's more orderly arrangement of atoms. Again, still looking at minimum energy. And then it does have energy to break that lattice apart. And when we look at it, it's called lattice energy. And this is the energy released when 1 mole, there's that mole, it's going to keep creeping back to us, of crystalline solid is formed from gaseous anions. Well, what we find in ionic bonding is that sometimes we have elements that have more than one, or we have a molecule, I should say, that actually has a charge. And these are called polyatomic ions. So these are covalently bonded elements that form ions, which then form the ionic bond. So covalent means that they're sharing electrons. So we've got a covalent molecule that these are all going to come together, and they kind of act as that positive or negative element. So what would that look like? Well, we're going to show it like so. If we have NH4, we're going to show that it's a cation because it has that positive charge. So if we were doing a dot structure with this, it's going to be the same way that we were looking at it. So we still have our pot, and we're still going to put electrons in. So we're going to put N in the pot. So that gives us 5. And we're going to put H in the pot. And remember, we have 4 of them, so H gives us 1 times this 4. So it gives us 4 in the pot. And this equals 9 electrons. So if we start building this, we have N, and then we have 4 H's. So 1, 2, 3, 4. So we have subtracted out 8 electrons. Remember, 2 for each dash. So that leaves us with 1 electron in the pot. Well, what am I going to do with 1 electron? It's not going to go on any of the H's. N isn't one of those exceptions, so I have nowhere to put it. Well, that's where this positive comes into play. So if it has a positive charge, it means that we have lost 1 electron. That's the only way we're going to have a positive charge. So by having this, we know that we're automatically taking out 1 electron. So if we're taking out 1 electron, it means I have 0 left in the pot. So it has removed that 1 electron. Now all I have to do is make sure everything has an octet, which it does. So to show that I was able to actually build this molecule, I'll put it in brackets, and I put the positive on the outside of the bracket to show that in order to have this, I have lost 1 electron. Let's try one more. This time we're going to look at an anion. So if we put our pot together, N once again gives me 5. O gives me 6. I have 3 of them, so I multiply it by 3, which gives me 18. So I'm going to put 18 in my pot. And 18 plus 5 gives me 23. Now, before I start adding things, I need to think of what this negative does. Well, the negative means I have more electrons. So in this case, I'm going to add 1 electron. So I'm going to take 23 and I'm going to add 1 electron, which is going to give me a total of 24 electrons in my pot. So now I start adding N, attach an O, attach an O, attach an O. 2, 4, 6. So I'm going to subtract out 6, leaving me 18 electrons left in my pot. Double them up. 2, 4, 6, 8, 10, 12, 14, 16, 18. Now, check your octets. O is good. O is good. O is good. Oh golly, N is not. So N needs to steal an electron, or 2 electrons to get its octet. Uh-oh, how is N going to do that? We can choose. If we choose, so I'm going to choose these, and I'm going to put them here. Well, N has an octet now. So we know we can make this if we have a negative charge. But N also has resonance. So that means we would have how many other things to draw? 2 more. So we would have something that we'd also have to draw, N with a double bond here. Don't forget the bracket to show negative. And we'd have to draw the last option showing all these extra electrons and our bracket and our negative charge. So since we have resonance, we would show the different molecules. Once you can prove to me that you know what resonance is, I will allow you just to write that this molecule has resonance and not actually have to show me all of those different structures. One more, SO4 minus 2. So we've got our pot. S is group 6, so it gives me 6 electrons. O is also 6 times 4, so that is 24. So we're going to put 24, which gives us a total of 30. Now we got to deal with this. Minus 2 means we need to add 2 electrons to the pot. So 30 plus 2 gives me 32 electrons. Start building. S, O, 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 O. 2, 4, 6, 8. So I need to subtract 8. So I no longer have 32, but I have 24 electrons left. So start pairing them up around the outside first. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Check for octets. So O is good, O is good, O is good, O is good, and S, yay, is also good. It's got 2, 4, 6, 8. So that means my structure is good if I have those extra 2 electrons. And that is your Lewis dot structures. You have plenty more to practice in class.